Hi, I will discuss with you what is spontaneity of redox reaction. But first, let us define what is spontaneity of redox reaction. A positive voltage that forms across the electrodes of a voltaic cells indicates that the oxidation reduction is a spontaneous reaction. As long as we can identify the actual reduction and oxidation processes that will occur in a redox reaction, the general description of the standard reduction potential for any redox reaction would be this. Thus, the standard reduction will be positive for the case where the reaction is spontaneous. The standard reduction will be zero for a redox reaction at equilibrium. The standard reaction will be negative for the case where the reaction is spontaneous in the reverse direction. Note that there is no reference here to what is the cathode and what is the anode. This next video will help you to understand more about spontaneity of redox reaction.
Name is a question like this: true or false? Under standard conditions, zinc can reduce nickel 2+. What makes this different from the battery is when we did a battery always had to be spontaneous, and so we forced the reaction to be the way that would give us an overall spontaneous reaction. In a problem like this, we can't do that. We have to follow the way the question is worded. So for example, here we want to reduce nickel 2+. So we look at our list of standard reduction potentials and you find this half reaction. Nickel 2+ is reduced to solid nickel and the standard reduction potential is a negative 0.26 volts. If our nickel 2+ is being reduced, the zinc has to be oxidized. So remember, when you look at the table, it's all standard reduction potentials. You have to flip them to turn them into an oxidation. So you can find zinc, after you flip it, being oxidized to zinc 2+, losing 2 electrons. The standard oxidation potential, instead of a negative 0.76 like you see in the table, because we flipped it, it's going to become a positive 0.76 volts. If you take this reduction and this oxidation, the key question is what kind of reaction do you get, and that is answered by what kind of number you get for the cell voltage. The only thing that matters for a question like this is whether the answer is going to be positive or negative. And negative 0.26 plus positive 0.76 is going to give you a positive answer. So because this is positive, that means it's spontaneous. And that means that the original question is true. Similar question in part B. True or false? Iron 2+ can reduce copper 2+. So if we're trying to reduce copper 2+, we can find that in the table the way it's written. Copper 2+ plus 2 electrons makes copper. This has a standard reduction potential of positive 34 volts. And there is another value in the table. Copper 2+ can be reduced by gaining just 1 electron and forming copper 1+. The standard reduction potential for this half reaction is a positive 0.16 volts. So we have two possible reductions. When you look at iron 2+, iron 2+ in this example can't be reduced because then we would have all reductions. So we have to find iron 2+ being oxidized, and we can find it turning into iron 3+, and the standard oxidation potential is a negative 0.77 volts. So in this case, there's actually two possible reactions that can occur. We could take the first reduction and pair it up with this oxidation. Positive 0.34 and negative 0.77 is going to give us a cell voltage that's negative. So this reaction is not spontaneous. We have to take into account the other possibility, which would be the other reduction with we only have one oxidation. If we pair up positive 0.16 and negative 0.77, it's still a negative cell voltage. So both possibilities give us an answer that's non-spontaneous, so this is a false statement. Iron 2 plus cannot reduce copper 2 plus. If one answer were positive cell voltage and the other answer were negative, the answer would be yes. If you have one possibility that gives you a spontaneous reaction, then the answer to the question is yes, the reaction will be spontaneous. And then for part C, true or false, H plus can oxidize magnesium. So the magnesium's being oxidized, we find that reversed in the table and we flip it to give us this oxidation. The standard oxidation potential is a positive 2.38 volts. The H plus has to be reduced, and we can find that in the table. H plus is reduced to hydrogen gas. Standard reduction potential is 0 volts. When you put this oxidation with this reduction, you get a positive cell voltage, which means it's spontaneous. So this statement is true. Notice in this last example, I had different numbers of electrons for the different half reactions. You never multiply a voltage by anything, so once you get these voltages written correctly, the only thing that matters is whether the result, when you add them together, is going to be positive or negative. You don't multiply a cell voltage by any constant.
Thanks for watching my video. I hope you learn more.